Installing and testing thermostat with ESP8266 and touchscreen. Hey, what's up? Nasir Malik here. Welcome to another IoT tutorial. In this tutorial, we will be completing our first thermostat prototype, printing out 3D case and installing it. So I will be putting it through its paces and find new defects, and the one that already exist, I know I will fix them and get it ready for the prime time. Code will be uploaded to GitHub, and all the part list will be in the GitHub and also in the video description below. So okay guys, so here is the diagram. I'll show you how you need to connect everything. I took a picture of my thermostat downstairs and I drew this diagram to explain how everything needs to connect. So if you look at it, I have 5 wires in the thermostat, and the red one, which is C right here, says, and it has also a jumper to R. This wire is for power. We have a Y wire, which is yellow, which is for cooling. C wire, this is a common wire. Basically, it is used to power the thermostat. You can power it without the batteries. If this wire is missing, that means you have to either use batteries, or you need to steal some of the power from all these 3 wires to power up your thermostat. We may cover that in a future tutorial if there's enough demand. The common is basically for the powering the thermostat, and then W, which is white one, is for heating, and G, which is green one, for fan. So let me explain how this works. Let's say if I want to turn on the cooling. So first thing I will do is set the D1 to high, and D1 in turn go and turns on this LED. So basically what these 3 are, these are DIY opto couplers. So there's a LDR inside here and there's a LED. So when LED comes on, it actually let the power flow through, current flow through the LDR, and in turn it goes to G and it turns on the fan. The next thing we do is turn on the D4. Turn on means set it to high, and that goes the same way in there, and it lights up the LED, in which in turn let the current flow through to Y, and the cooling is on. So basically letting the current flow through from power through here to the Y, it will turn on the compressor, and this will turn on the fan. So if we want to turn it off, we'll basically go through and do the same thing, set the D1 to low and the D4 to 1, and it will shut it off. If I want to put on a heat, basically I would do same thing again, set the D1 to high and it will turn on the fan, and then set the D3 to high and it will turn on the heating. So next, to power the thermostat, what we do is we take the common wire and we connect it to the bridge rectifier on AC side. It doesn't matter which leg you connect it to, and the other wire goes to the other leg, which is the power wire, and this will connect to other wire, and this is also common in the LDR side. It's connected to the same wire. So this is the AC side. So on the other side, on the bridge rectifier DC voltage, you can see the minus is common and it's going to, negative is going to the capacitor, also it goes to the ground, and Wemos mini, and also on the legs on the LED on the negative side, and also to the touchscreen. And on the positive side, you can see it is going to the capacitor and also to the voltage regulator or converter, whatever you want to call it. So this one is really tiny. It's actually smaller than the capacitor, and I'll show you in a minute. But what it does, it takes anywhere up to 30 volts. It could be 20 volt, whatever the current input is. It doesn't matter. It can't be higher than, I believe it's 30 volt or somewhere around there. I don't exactly remember. But for me, it's working fine with 30 volt. And then the output from here, you can control it setting this potentiometer. So before hooking up everything, what I did is I connected the bridge rectifier and the capacitor and also the voltage regulator, and then put my multimeter on it, and then I used the pod to set it to 5 volts. So I'm using 5 volts because the Wemos Mini is 5 volt tolerant because it has a voltage regulator. Also the touchscreen needs 5 volts. And here I'm just showing what is inside this package, the 3 of my build. There's a LED and there's a LDR connected. Okay, once you download your sketch, you need to open it in Arduino IDE. You have to do few things before you can use the sketch. First thing is you need to put in your SSID name and then the password for your SSID. Make sure it's 2.4 gigahertz. Also, if you're using the Wemos Mini and you're using the same pin I am using, then you don't need to change any of these pins. These can stay what they are. But if you're using a different board or you want to use different pins, you have to change them here. Also, the Nextion communicates with Wemos with these 2 pins. That's how I have them hooked up. You can also change them here if you need to use the different pins. I did have issues using some other pins because I have it connected to my computer and trying to upload the firmware, and there's an issue. So I try to find the pins that work the best, so I can have the Nextion connected to my Wemos, and then also I'm able to upload the sketch without any issues. So these 2 pins are working for me fine. Also the resistor you're using, so you have to make sure that resistance is close enough to your thermistor resistance. Mine doesn't match exactly, but there's a little bit difference, but that is fine because when you do calibrate it using the method I showed you in one of my previous videos, once you do, you have to put these values in here. So even if it is a few degrees off, you can always manually adjust it. That's not an issue. So these 2 variables are key to making sure that we are consistently turning on and off and getting a consistent temperature reading. So this one is a fan delay. So basically the idea is once, let's say if we want to put a heating on, so for that we have to make sure the fan goes on and then the heating goes on. When we turn it off, we need to make sure the heating is turned off first, and then there's a delay for the fan to be turned off. So I have like a half a minute delay in there. You can actually adjust it, put however you want, but make sure it's not more than, you know, a minute. So make sure it's not too big, otherwise you will run into issues. And this is basically we're using Thermistor, and it's very sensitive. If you see in some of my previous videos, you touch it slightly or something, and then the temperature goes up very quickly. I mean, I'm talking about seconds, you know, 1 or 2 seconds ago. So that is an issue for the thermostat, because we want to get a consistent temperature reading, and we want to make sure that it's not fluctuating. If it is, it's gonna keep turning on and off your unit, you know, AC or a heating unit, and that is not good. So what we have to do is we have to run a running average, and this is what I'm saying. You know, I want you to do 20 sample and then basically creating arrays, and then take a reading after every second and put it in and then get the average to smooth out. If you need more smoothing out, just simply increase this to 30, 40 or 50, whatever you need. But for me, on the 20 is working fine. And rest, you see, these are some of the variables that I'm using throughout the system. The code needs to be cleaned up, but for now it is working the way it's supposed to be, and we're pretty good. And here is the function, running average. Basically it is calculating, you know, reading it from the analog, and then it's basically which is Thermistor, and it's printing it out, and you can probably see it. It is printing this out right there. And so what let me show you one more thing, so before we move on to a different. So what I did is I need to control 3 things. So I want to update the time and since the Wemos doesn't have any built-in clock, so I need to go grab it from the internet, and I do this every 1 minute I update it. And the second is unit control, which runs every 15 seconds. And I can show you what is in there. So unit control is basically looking at what the current temperature is and what the units our thermostat setting is, and accordingly it turns on and off the unit. And there's a 15-second delay for it, so you can't go turn it on and off, turn it on and off, and it won't. So that's why I'm running this in a timer. And the running average is 1 second. We're doing a sampling for Thermistor. Basically this is doing to work around the analog noise. So these three basically timers, they're running, and they accordingly update whatever needs to be updated. And here's some of the logic for unit main control. Based on what you select on LCD, this keeps executing every 15 seconds, and it will turn on and off the AC. And here is the delay for the fan that I was talking about, that the logic to control the delay of the fan. So unit, if the heating, let's say if you set the temperature to 70 and temperature goes up to 70, then unit will turn off, the heating will turn off. But it will take 30 seconds before the fan is turned off, because it will try to get residual heat from the heating unit to make sure that it's able to push it into the building. So what I'm gonna do is demonstrate here these LEDs going on and off. So right now I set it to cool, and the temperature is 85, and the current temperature is 85 also, the set temperature, so desired temperature. So what I'm going to do, I'm going to change the temperature, and I'm going to see the fan light is coming on and the cool light is coming on. So let's drop the temperature to 84 or 83 maybe, and I'm expecting to see this light going on and this light. This light will turn on and this light will turn on. So as you can see, this light LED is on. This is turning on the fan, and then this one is on, turning on the cooling. So once temperature is set to desired temperature, the current temperature, desired temperature is equal, then it will go ahead and turn off. So as you can see, it's turned off now. So now I'm going to put it on the heat, and I'm going to up the temperature. And then the fan light should come on, and also the heat light should come on. And you can see they're both on right now. So once the temperature, the current temperature reaches to the desired temperature, then it will turn off. So let's manually change it. So 84. So let's drop it to 84. And you should see this light going off, and also this one. So here is, I'm going to remove my current thermostat, and I'm going to go ahead and calibrate voltage regulator to the 5 volt. So here I'm connecting the one alligator clip to the power, and the other one to the common. On the other side I have connected to the new thermostat, and I have not connected the output of the voltage regulator to the thermostat yet. I am using the multimeter to adjust it to 5 volt using potentiometer. Remove all the wires, and then take electrical tape and cover them up, so when I replace it with my new thermostat, they're not going to short, because I already shorted it and I had to go and get a 3 amp fuse and replace it. So before you unhook the wire, take a picture with your camera or write it down. We have the new thermostat is gonna have the same configuration of the wire, so remember the colors. So I'm going to go ahead and have it install it in the same way. And make sure you careful when you're removing the thermostat. If you drop the wires in the wall, it's gonna be really difficult to get them out. So make sure you spread them out, and then go ahead and install the new thermostat. Here you can see I try to use a double-sided tape, but my PCB is keep moving, so and that's why I put in a one screw only, because I want to test it out to make sure that it's working. And I'm gonna try to maybe modify the thermostat case and then screw it in, or find a better solution. This is just to test it out. Still work in progress. It is not ready for prime time, but it is working. And one more thing I wanted to make sure share with you guys. I put in the thermistor, as you can see, on right underneath the Wemos board. Maybe that is not a good spot to put it, because when I closed it, it was showing much higher temperature, because the Wemos getting hotter, and is affecting the temperature. So, and also on the 3D case, I only have two-sided vents. Maybe I need to put the vents on top and bottom. So here I'm basically setting the current temperature to 85. So I want to make sure that it is turning on the fan and the heat is coming on. The temperature is not accurate, but it is working. So okay guys, let me explain what I have done here so far. So I have these terminal blocks right here. There's 5 of them total. I have the way I connected these underneath the board. It's pretty messy, so you can't tell really clearly where it's going, but I'm gonna explain it and leave the picture in there so you guys can take a look at it, how it's connected. So basically these 3 are the opto couplers with the LDR and LED. I have a diagram that tells you what type of LED I'm using and LDR. And I have 2 capacitors here. This is to smooth out the voltage for the Wemos, and this is to smooth out the overall voltage. And there's a bridge rectifier, pretty small one, underneath the board, as you can see it here. I have given the value in the diagram. And also there's 4 pins connected here, and there's some couple of wires coming, one negative and one positive, and then the other one for RX TX for the LCD display. And then thermistor is right here, is connected through this resistor as a voltage divider. And you guys can see in a wire diagram how it's connected, but just want to explain. So if you look at the voltage regulator, this is a very small one. I mean, if you look at the capacitor itself is much bigger than the voltage regulator, and it does a pretty good job. So there's only 3 legs. The ground is common for input and output, and there's input V in takes up to, I think, 30 volts, around there somewhere. And then V out is the adjusted voltage, and I adjusted to the 5 volt. I'll show you in the video also. You just need to have a multimeter and make sure you set it to 5 volts. So this is it. There are not many parts other than that. And then just a terminal explain you. So the terminal this is the power, and this is for the cooling, and this is for the common, which is power to power this board, and also the Wemos and the LCD, and also this is for the heating, and this is for the fan. So this is exactly my thermostat is hooked up. So this is how I wired this one also. And I put these instead of soldering the board, I was having some issues while I upload the firmware on this board. While it's in there, it causes some problems, so I took it out and uploaded the firmware on it, and after that I plug it in, and then it works fine. So this is my first prototype. It doesn't look very nice underneath it, but I'm thinking eventually I'm gonna go ahead and design a PCB and professionally printed PCB I'm planning to do with ESP32 and ESP8266, two different kinds. Maybe ESP32 makes more sense because it has a Bluetooth and it makes it easier to integrate it with the mobile devices. So here I will show you how to build the optocoupler and also speed build the entire project. So if you need to take a look at it, please pause the video and you can view it. If you have any questions, please leave it in the comments below. Thank you. So guys, for the next tutorial, I'll be adding a PRI motion detection and also the mobile app to control the thermostat. And I may do this slightly differently in maybe ESP32, but it'll be a similar concept. So we'll go ahead and build on that. So until next time, bye. you.